Hey guys, this is Mr. Murray here. We're going to take a quick look at the scientific method. We've talked about it briefly in class one day last week, but some of you may or may not have been there for class, so I just want to give you a quick overview of it, maybe send some questions on to My Big Campus or something like that for you. So let's see what we can find out about the scientific method. First thing you need to do with the scientific method is you need to decide what's your question, what problem are you wanting to solve. You can ask yourself different questions. Make sure it's something that is you're interested in, or really spend some time with it. What is the one thing you're wanting to look at? We'll look at many different questions and problems as we go through our science this year, but this is the first step in the scientific method. The next step is to do research. After you decide what your problem is you're going to solve, you need to look some information up about that topic. The research must be based in factual information. Wikipedia is not factual information. It's a good resource, but Wikipedia and Ask.com are not always based in the facts. You need to find multiple resources so you can get the most information so that you may create your hypothesis, your educated guess about your project or whatever it is that you're working on, what your question was about. Next thing is we come up with our hypothesis. Hypothesis is an educated guess based on the data from your research, and it helps you decide what it is you're going to try to prove. You need to look at it, come up with an educated guess, and go, okay, this is what I'm going to try to prove. You must back it up with that research, and it needs to be written in an if-then statement. If I do this, then this will be the outcome. Procedures and materials. Those are very important, guys, to make sure we have what we need for our experiments. Procedure is how it's done. It's the step-by-step breakdown for how you're going to do that project or how you're going to do the experiment. And materials, it's the things that you need to have to complete that experiment. And you want to write both of those so that if someone else decided to redo your experiment later on, that they would have the needed information to do so. The experiment. This is where you get to put your hypothesis in action. You need to do your experiment, see what goes on with it, record your observations, make sure it's very detailed, keep the data because you're going to analyze this data to help you learn more about what your question was and what you were trying to find out. Then we go to analysis. Analysis is when you put the information that you gathered into some sort of tool you can put it in a graph, in a chart, something like that you get to look at and see the information for what it is. Don't add things into it. Take the data just what it is and add it in so that you can see where you went in the process. And finally we come to the conclusion. This is where you will share with others the information you gained through your experiment. It will state whether you were correct or not correct about your hypothesis. It must be backed up with data from your experiment. Now, it's not a big deal if you're right. It's not that big a deal if you're wrong. It's just about going through the processes and recognizing, okay, I did this, but maybe I need to do this next time so that I have an experiment that does what I say it's going to do. And if it doesn't do it, and it continually doesn't do it, that's okay. Because maybe it's a variable in there. Maybe it's something that we need to change or check out. So that's okay. And your hypothesis needs to be in your conclusion that your hypothesis was either correct or incorrect. And you also need to say the data showed that. So whatever the data showed, you need to state it in that conclusion statement so that we can see what was going on so you can share that information. Scientific method is a great tool for sharing information about your experiments. It's a great tool to use for problem solving. I hope that you enjoy using it. We'll be using it all through the year. And I just wanted to give you a quick little overview of it so that you have additional information as we go forward in using the scientific method in science this year.